Welcome back to another cool tool show and tell. Today my special guest is Ian Charnas. Ian is an engineer, a makerspace founder, and a YouTuber who makes hysterical inventions and then auctions them off for good causes. Ian, thanks for joining us today, and what did you bring to show us?
Well, behind me I've got two Epilog laser cutters, which we're very happy to have. But these tips I'm going to give will work for any laser cutter out there in existence today. So you don't have to have this particular brand or maker model, which is good. So the first tip we're going to go over is a common one that people want to know how to improve. So this is the back of some material that I have laser cut, and this charring here is caused by the process of laser cutting. So what is laser cutting? You're using a laser beam to catch stuff on fire, and then compressed air blows the charred remnants of your wood or plastic or whatever it is out of the way. So you are causing fire, and the smoke from that fire, meaning the vaporized plastic or wood or what have you, that can then get redeposited, including its carbonized content, onto your material. And so a common tip that it's very, very good to have as you're scaffolding your experience is to leave the plastic liner on this plastic while you're laser cutting, so that as you peel off this plastic liner, you don't have those char marks on your finished workpiece. And you can even use this technique for etching. So I'm going to show you an example. This is some green iridescent, sort of neon colored plastic that has this paper liner on it. And if you take a look at this example here, you can see radioactive hydrogen. This is a piece of my next video. I'm not going to give away the secret just yet, but it's let's call it a DIY nuclear reactor. So you can see how good the etching looks. There's no charred remnants. I wonder if we can get this in better focus here.
It was in focus for a while, so we got a good shot of it. Yeah, it looks great.
Okay. So tip number one is to keep both liners on while you're cutting and while you're etching. That's a good tip as you're getting started. One more thing we can add is that if you are cutting or etching material that doesn't have a paper liner on it, for example, you buy a piece of plywood, you can use masking tape to cover the surface of your wood or your other piece of material that doesn't have that liner on it, so that when you go to laser cut it or laser etch it, you'll get all the benefits of the material that came with a liner on it.
Great. See, I snuck in an extra tip there. Yeah, thank you.
Excellent.
All right, I'm ready. What's the next step?
Okay. Tip number two is pertaining to fire. So I mentioned that you are causing fire, and it's really relatively common that material in the laser cutter will catch fire unintentionally. So those charred remnants and half-burned pieces of plastic and wood, they fall down into the laser cutter bed. There's a tray that catches the half-charred remnants. And it can happen from time to time, especially if you don't clean your laser catch tray out regularly, that a fire will happen in that tray. And you have a couple different options for putting it out. If it's your workpiece that's on fire, and that'll happen quite often, especially if you try to cut paper, you can take a piece of Nomex. This is a material, don't worry, it's not made of gnomes. This is a fireproof fabric, and Nomex is the trademark. This can be bought on Amazon, and we can give the link to it. And you can just use this to stamp out the fire. Even if there's a relatively large fire, I'm confident enough that this material is going to stop the fire that I'll sit there and pound it out, even though I'm holding the other side of the material. With this, you can really have no fear. You're going to be able to stamp out the fire. Now, if the fire is in a place where you can't reach the base of it and you need a fire extinguisher, I highly recommend that you don't use a dry powder fire extinguisher. So your typical fire extinguisher, if you go get one off your wall, whether it's one in your kitchen or one in your workplace. It's going to be a dry powder, type ABC. They're often called, meaning that they work on 3 different kinds of fires that can happen. If you expel that dry powder into your laser cutter, it's going to coat all the optics. It's going to coat the encoder strip that lets the laser cutter head know where it's at. It's going to interfere with electrical contacts. It's going to make your life miserable. You'll be cleaning that for a month to come with tiny little Q-tips soaked in alcohol. It is horrible. Please, before that fire happens, that you need a fire extinguisher for, get a different kind of fire extinguisher. If you could get a CO2 extinguisher, that would be great. Carbon dioxide it starts as a liquid, it puts out fire, and it doesn't leave any residue because it's just a gas. But most places, like where I'm at right now at a university, we no longer use a CO2 fire extinguisher because it's a greenhouse gas, but more importantly, because it's an asphyxiant. It can suffocate you. If you inhale it too much, it displaces oxygen in a particular kind of way that can cause a human health hazard. So what do you use? Thanks to our friends in server rooms across the world, we have a third option. This looks like any other fire extinguisher tank, but inside here is an ingredient called Halotron. Let's see if you take a look at this green label right here. Halotron.
It sounds like a cool band name.
Yeah, it kind of sounds like either a cool band name or like some futuristic Star Trek BS that like powers their new warp wavelet engine. This is somewhat similar to CO2 in that there's a liquid inside this tank, and I can feel it sloshing around. But if I were to spray this, and I'm not going to because this stuff is a little expensive, it puts out the fire, it evaporates, but it's not the same asphyxiant hazard that carbon dioxide is. So this is something that's safe to use and legal to use in states and in office buildings and makerspaces where you don't want to have that CO2 because of the potential for the human health hazard. So tip number 2, you're an intermediate now. You know that fires happen in laser cutters. You should have something to stamp out fires, and you should have a fire extinguisher nearby. And I am highly recommending that your time is worth something, and you don't want to be cleaning the dry powder out of your laser cutter. So get a Halotron fire extinguisher.
What else do you have for us?
You ready for tip 3?
I think so.
So we've done our regular brain tip, we've done our giant brain tip, and now it's time for our galaxy brain tip. And I'm gonna need a whiteboard. Look what I just found.
Conveniently located, yeah.
I'm at a university. We wouldn't make it very far without whiteboards. Here I go. Here's the colors I wanted. Okay. So in your laser cutter, there is a laser, right?
True.
See if we can, yeah.
By definition.
Can we see all that in the frame?
Yep.
Is that, yeah, it's still, okay. This is our laser. What comes out of that laser? What comes out of that laser is a column of light. Okay, and I'm going to draw an arrow here just to make it super obvious that the light's going that direction. Now inside your laser cutter, you have a series of mirrors that redirects the path of this relatively wide, meaning kind of low power density, column of light. I'm going to draw one of those mirrors. That's a 45-degree mirror. So of course what happens when the laser hits that mirror is that the light is redirected downward, and then it goes into your lens. You kind of know that there's mirrors and lenses in the laser cutter, and you know that there's a laser tube in there somewhere. Here's our lens. What happens when it hits the lens? The lens, just like any lens, will focus the light. Okay, so I'm going to draw that coming to a focus point. When you focus your laser cutter, whether you use the automated focus, the autofocus, or whether you focus it manually with a gauge, what you're doing is you are focusing, you're changing the height of your material so that it matches the point at which this beam is its most focused, its most narrow. And here, we're about to get to the galaxy brain part. This is your material. What happens when the laser cutter, when this laser hits that piece of wood? Does the laser just keep in a perfect, laser pointer style, incredibly fine column? No, the laser does what all light will do. It will then defocus. It will then defocus. And so what does that do to your workpiece? When you cut your workpiece, the cut is going to have this bevel to it, right? So if you've ever tried to cut a thicker piece of material and you've noticed that the side walls of your hole or whatever you're cutting are not perfectly straight up and down, maybe you've noticed that they're a little bit beveled. This is why. And why does that matter? If you're trying to mate parts together, if you're trying to design dovetail style joinery, boxes that fit together, enclosures, if you want to have accurately sized holes for your switches and buttons and your LCD screen to fit through, you want to get the most accurate sized holes you can. So here is your galaxy brain tip. This is your advanced tip. First, you focus that laser, right? Now you know that when you're focusing your laser, there's some way for you to move that laser cutter bed up or down by a few thousandths of an inch at a time. On some laser cutters like these, it just tells you, hey, you're moving at 5 thousandths of an inch at a time. And you can adjust that. I can move at 10 thousandths of an inch at a time. On other laser cutters, it doesn't tell you how much you're adjusting it each time you bump it up or down. You're just trying to match a manual gauge height. But what you can do is you can use calipers or another measuring tool to measure the difference in height that the bed makes each time you nudge that bed up or down. Once you know that, you can make a galaxy brain move, which is this. First, you find an eraser. Okay, we're going to go back in time. We know that the laser will focus to a spot. And we know that when you focus your material, it's just going to be here. But what you're going to do with your galaxy brain is you're going to move the bed up a little bit so that the material, so that the laser cutter has its focal point in the middle of your depth of material. And you will end up with a minimal bevel in your material. And you'll end up with the most accurate possible cut that you can. Now, how do you do this? If my material is 1/4 inch thick, I'm going to focus to the top of the material, and then I'm going to move the bed up 1/8 of an inch. And then I will have the most perfect, as bevel-free possible cut as possible. And that's your galaxy brain tip for getting accurately sized parts.
Where can people learn more about what you're up to and what you're doing? And what do you have planned for the future? Two-parter.
Anyone interested in hearing more about my projects can follow me on YouTube, youtube.com/Ian Charnas, or you can follow me on Instagram, Twitter, Facebook, where I'm also available as Ian Charnas. I showed you this little test strip earlier, and I gave a hint that I'm making a nuclear generator. So I found a way to make a safe DIY nuclear generator, and I'm making an Instructable to show you how to do this at home. At least until the Nuclear Regulatory Commission stops me. And I'm going to be making a video about it. And the goal is to make a nuclear generator that can output enough energy to run a video game. This is not an incredibly large nuclear reactor, but it is kind of a conversation piece to show your friends. And it does use radioactive hydrogen in a way that's safe to use at home. So if that piques your curiosity at all, and if you want a chance to win, I'm going to be raffling off this nuclear generator. Go check out my YouTube channel. Make sure you click subscribe and make sure you click that bell.
I think there's no way that people will want to miss something like that. So that's great. I'm looking forward to that one personally. All right, Ian, you've cleared a lot up here for me in terms of laser cutters, and I'm excited to to have people see this video. Now, if you made it this far in this video, you can see links to everything Ian's talked about down here in the description for the video. And you can see thousands of reader recommended tools like these at cool-tools.org. Thanks again, Ian.
Thanks, Donald.